Welcome to The Explainer. Today, we're jumping right in to decode the technologies that are literally poised to redefine life, intelligence, and, well, humanity itself. We're talking about a convergence of forces so powerful it's not just creating a new future, it's also rewriting our past.
Okay, so to get our heads around this, we need to understand one key concept: G.R.A.I.N. It's an acronym for genetics, robotics, artificial intelligence, and nanotechnology. And the key word here is converging. These fields aren't just running in parallel anymore. Oh no, they're merging, they're feeding off each other, and they're accelerating in ways we've never seen before.
You can think of these as the four pillars of this new era. You've got genetics, that's all about reading and writing the code of life itself. Then robotics, which is building the intelligent machines that can act in our physical world. AI, which is, creating the minds for those machines. And finally, nanotechnology, engineering matter from the atom up. It's how these four come together that makes this moment so unbelievably transformative.
So, here's how we're going to break it all down today. First, we'll look at how we're hacking the code of life. Then we'll get into how we're building totally new forms of intelligence. From there, we'll explore what this means for the definition of being human. And you'll love this part. We'll see how it's opening up a new window on history. Finally, we'll tackle the massive ethical questions all this power brings with it.
All right, first up, we are now in an age where we treat DNA less like biology and more like, computer code. It's the fundamental programming language of every living thing, and we are finally learning how to read it, debug it, and even write our own from scratch.
And this is the key idea right here. It's a simple analogy, but it is so profound. Every organism, including you, is running on a software made of A's, T's, C's, and G's. And once you start thinking about it that way, the idea of editing that code just becomes the next logical step, doesn't it?
What you're looking at here is a fascinating, invisible arms race. On one side, we've developed tools like CRISPR. Think of it as a find and replace function for DNA. It lets us edit genes with pinpoint accuracy. But, and this is amazing, on the other side, nature has its own defense systems, anti-CRISPR, which can literally block our edits. It's a constant battle playing out at the molecular level.
This power completely changes our role in the universe. We're going from being just editors of the book of life to asking, can we be the authors? Can we design and build entirely new life forms, right from the ground up? That is the big question on the table now.
And this isn't some distant future scenario. These applications are here, and they're already pushing every ethical boundary we have. We're talking about modifying an astronaut's DNA for a trip to Mars, creating babies with 3 genetic parents to prevent horrible diseases, even developing human-animal hybrid embryos for research. Each of these is a real-world dilemma, where we are, quite literally, rewriting the rules of life.
Okay, so this revolution isn't just about rewriting biology. We're also writing completely new code for brand new kinds of intelligence. Some of these are biological, some are purely digital, and some are this wild mix of both.
This spectrum of what's being created is just staggering. On one end, you have things called xenobots. These are the world's first living, programmable robots, made from frog cells. They can move, they can work together, they can even self-replicate. And then on the other hand, you have these giant digital minds, like Google's Gemini, an AI that's learning to understand and interact with our physical world.
And get this, the way we're teaching these AIs is changing too. Instead of just cramming them full of data, we're designing them to learn like a human child. It's called a constructivist approach. The AI literally explores its world, it builds its own internal models of how things work, it tests them, and it learns from its mistakes. It's less like programming and more like, raising a new kind of mind.
So as these technologies get more and more powerful, they stop being just tools we use, and they start to blur the line with our own bodies, our own biology. This forces us to ask a really fundamental question. What does it actually mean to be human anymore?
And this used to be pure science fiction. But now, it's a serious question being tackled by actual neuroscientists and tech billionaires. The concept of immortality 2.0, the idea of digitizing and uploading a human mind, is shifting from a philosophical what-if into a technical problem that people are trying to solve.
And that leads to this just radical shift in thinking. I want you to really consider this question. Will aging soon be a maintenance defect? What if getting old isn't inevitable? What if it's just a bug in our biological software that could, one day, be patched? That one question completely reframes our relationship with life and death.
Now here's a twist I love. You'd think all this high-tech stuff is only about the future, right? But what's so fascinating is that these tools are also giving us this completely unprecedented window into our own deep past. They're turning history into a live investigation.
For centuries, we had this field called codicology. It was how we looked into the past. Historians would study old manuscripts, the ink, the paper, the binding, to understand how knowledge was passed down through the ages. It was all about the physical object.
Well, now that field is being reborn as biocodology. We are figuring out how to use DNA, the molecule of life itself, as the ultimate hard drive, and the storage density is just insane. I mean, you could theoretically store all the data in the entire world in a container about the size of a shoebox. We're connecting ancient scribes to the absolute future of data.
And this is already happening. Police are using consumer DNA databases to solve cold cases that have been sitting there for decades. Scientists are pulling ancient DNA from fossils and completely rewriting the story of human evolution. We're even using AI and genetics to try and decipher unreadable ancient texts. History is becoming a forensic science. But of course, with all of this incredible power comes some pretty immense responsibility. This grain revolution isn't just a technical challenge, it's a moral one. And it is forcing us to face some of the hardest questions our species has ever had to answer.
I mean, really, when we can create human-animal hybrids in a lab or edit the genes of our children for generations to come, who gets to draw the line? Who makes the rules? Who decides what's okay, what's human, and what's off-limits? These are no longer philosophical questions. They are practical ones.
And what about access? Will these amazing breakthroughs, like cures for genetic diseases or treatments that extend our lifespan, be available for everyone, or will they only be for the super rich, creating a brand new biological class divide in society? This question of tech equity is absolutely crucial.
And then you have the risks that sound like they're straight out of a movie, but are being taken very seriously. For example, as we use AI to scan the stars for signs of intelligent life, could a message from an alien civilization actually be a piece of malware designed to hack the very systems we're using to listen? It's a real security concern.
Look, these are not problems for our grandkids to figure out. These are the urgent conversations we need to be having right now. How do we protect our own genome, our most personal data? How do we make sure the people building this future actually represent all of humanity? And how in the world do we balance letting innovation fly with the thoughtful rules we need to prevent chaos?
So in the end, the whole G.R.A.I.N. revolution really forces us to look in the mirror. We are going from being players in the game of life to being the designers of the game itself. And that's about so much more than just science. It's about the future of our species and the very nature of what it means to be alive. So, what do you think?